Welcome to GK TechVerse. Java Collections Framework. Every Java developer uses collections daily, but most can't explain why ArrayList is faster than LinkedList for reads, or when to use HashSet versus TreeSet. In this video, I will fix that with the exact explanation interviewers want. Before we discuss, I want to share one production incident which happened while developing e-commerce order processing system. Suddenly, order IDs started duplicating. The on-call engineer checked the logs, no exception, no error, orders just silently overwriting each other. So we found the root cause. A hash set was being used to deduplicate orders. But the developers had forgotten to override equals and hash code on the order class. The hash set was storing duplicate records because without those overrides, it doesn't know two order objects are the same. That one wrong collection choice cost the company 4 hours of downtime. Today we make sure that never happens to you. By the end of this video, you will know exactly which Java collection to use and why. Not just for interviews, but for real production code. That before Java 1.2, you had to use arrays everywhere. No dynamic sizing, no built-in search, nothing. There is a limitation in arrays. The Java collection framework introduced in Java 1.2 gave us a unified architecture for storing, retrieving, and manipulating groups of objects. It's a set of interfaces, implementation, algorithms that every developer uses daily. Three things you need to know. Interfaces define the contract, implementation are the actual classes like ArrayList, HashMap. Algorithms are utility methods like sort, shuffle, binary search. All are in package Java util collections. Collection hierarchy. Here is the big picture. This is the diagram that most developers have never seen clearly. Everything in the collections framework flows from two root interfaces, Iterable and map. Notice map does not extend collection. That surprises a lot of people in interviews. Let me walk you through each branch. Pause for a minute, read the question and answer. Here is now we'll see the list implementation from the hierarchy. List is the most used collection type, and it will allows you to add duplicate records and no size restriction. The two main implementations are ArrayList and LinkedList. ArrayList placing the orders in index based. The interesting fact here, searching records will be index based and it will be very fast. Adding a record at end is easy, but adding at mid level will be slow because it should shift the elements internally and it will be time complex. If you are working on a large records, then it is a performance issue. Removing also slow because it should shift the elements internally. Now we'll see linked list. It will store data like a doubly linked list of node objects. Every node will have data plus pointer to previous object. And most developers always they choose ArrayList by default without understanding why. Let me show you the difference with an enterprise example. Imagine an e-commerce platform storing product search results. Let's say you want to load 10,000 results and display them in pages. You need fast random access, right? Give me item at index 500. Then this case you have to use the ArrayList because it is very fast. Index based search makes you fast response. Now imagine a task queue in order management system. Whenever you receive order request, you want to process that from the front. New orders added at the back, right? Then this case you have to use the linked list as a DQ. So here I have shown when to use ArrayList and when to use linked list, right? Queue based, you can use linked list, and search purpose, you can use the ArrayList. And here you need to remember, don't use linked list for random access, because if you search for particular index, it has to traverse through the complete list and it will be very slow. Now we'll see set implementation. Set enforces uniqueness, no duplicates allowed. But how it enforces uniqueness and in what order elements are stored, that's where the three implementations differ. HashSet, which internally uses HashMap internally, order no guarantee order, and it will allow only null key. Performance, add remove contains O of 1 average. Time complex is very fast. Uniqueness check, fast lookup, order doesn't matter. So use case, you can use it when session token you want to store or deduplication pipeline, you can use the HashSet. If you see the LinkedHashSet, it which internally uses LinkedHashMap, and order will be insertion order. So if you want the insertion order, you can use the LinkedHashSet, and performance will be slightly slower than HashSet. And use when you need uniqueness plus insertion order. And enterprise example use case, dedupe search queries while preserving user search history. We'll see the TreeSet, which is internally uses red black tree, which is TreeMap, and ordering will be sorted. Performance will be add remove contents O of login. So the time complexity big O notation is O of login. Use when sorted unique elements and range queries. The enterprise use case you have to use whenever you want to show the leaderboard, like top and unique scores you want to display, or price range filters, you can choose the TreeSet. Back to our production incident which we talked earlier. If the developer had understood set properly, they would have known HashSet checks uniqueness using equals and hash code. Without overriding those on your order class, every order looks different to the HashSet, even if the order IDs are identical. So you have to override the equals and hash code, then only the HashSet on the concrete class will be maintain the uniqueness. This is very, very important. Now you can pause for a minute and you can read the question and answer. Now we'll see the map implementation. Map is a key value storage, the most widely used collection in enterprise Java. Think of every caching layer, every session store, every configuration object, they are all maps. The three main implementation follow the same pattern as set, because set is actually backed by map internally. HashSet uses HashMap, TreeSet uses TreeMap. Here is the real enterprise example. And LRU cache, so it means least recently used cache, we can implement using LinkedHashMap. Here if you see, we can cache top 100 product details in a catalog. LinkedHashMap with access order equals to true is the built-in Java way to implement LRU without any library. You don't need any Redis cache or any in-memory cache. You can use LinkedHashMap. You can keep the shortest small cache you can implement. Here in this case, if you see, I'm caching the top 100 product details in a catalog service. I can set the capacity, and whenever I push the records, recent frequently accessed products, when I pushed it, when the size is exceeds, which is automatically it will remove from the linked list. So this is the best way to use the LRU cache using LinkedHashMap. Now we'll see queue and priority queue. Queue is a first in first out data structure, which is FIFO. The first element added is the first one processed. But priority queue breaks the FIFO rule, which elements are ordered by priority. We can set the priority, and based on the priority, the order will maintain, not insertion order. Internally, it's a mini heap. An enterprise example use case, an order fulfillment system where VIP customer orders jump the queue. That's exactly what priority queue is built for. So here is the example, the code which shows priority by order. So we will set the priority. Based on the priority, the order will be generated. Now we'll see what is fail fast and fail safe. This is one of the most common interview traps. Developers know how to use iterators, but they can't explain why they sometimes get a concurrent modification exception. The answer lies in fail fast versus fail safe iterators. Every junior developer faces this bug. You are iterating a list and deleting elements inside the loop. Then you will get concurrent modification exception. Now here we can see which collection will have fail fast and fail safe. ArrayList, HashMap, HashSet will throw an error. Will get a concurrent modification error. Whenever you want to modify the same iterator, you will get concurrent modification exception. But what is the fail safe? So we can use, for arrays we can use copy on write array list. For HashMap we can use concurrent HashMap. We can see here the details. The fail fast collection, if you see ArrayList, which iterates on original collection, and what will happen whenever you are modifying that collection, the mod count will change. Whenever the mod count change, it will throw a concurrent modification exception. If you see fail safe collection, let's example copy and write array list, iterates on a snapshot clone. So it will take a snapshot of the original array list, and you can modify on that freely, and you will not get any exception. You can comment these answers. You can read these questions and comment your answers, whatever we discussed so far. Let's wrap this up with the one cheat sheet you need to remember. I'm going to show you the exact decision logic I used in production, and that I have. If you want a list random access by index, you choose the array list. Frequent insert and delete front, you go for linked list. If you want unique elements and fast and no ordering is required, HashSet. Insertion order is required, go for a linked HashSet. Sorted order, go for TreeSet. Need a map, key value basically. So fast and no ordering required, go for a HashMap. Insertion order is required, linked HashMap. If you want to build a least resource usage cache, that is LRU cache, and you go for a linked HashMap. And sorted keys, TreeMap. Thread safe, concurrent HashMap. Need a queue. First in first order, you go for array DQ. Priority based ordering, priority queue. Thread safe, blocking queue, linked blocking queue. The three things every interviewer wants to hear from you. You need to know the complexity, internals, and production wisdom. These are very, very important. That's it for today. If you learned something, hit the like button. It genuinely helps this channel grow. Drop a comment below with your answers. Thanks for watching GK TechVerse. Subscribe and keep upgrading your skills. See you in the next video.